In this video, I will cover the most common lab measurements source of errors. Basically, there are three main sources of errors during lab measurements. The first one is error from measuring instruments. This is the systematic error. The second one is errors from the experimenter or human errors. And the third one is errors caused by external influences. These two, the experimenter error and the external influences error, is the random error. Let me start with systematic error. Number one, instrument indicates a value greater than 0. Problem: these instruments indicate a value greater than 0. This is the Newton scale, so the mark here is not aligned with the 0 mark. This is the voltmeter, that the pointer is not on the 0 mark. The ammeter, the pointer is not on the 0 mark. And this digital scale is not showing 0.0 grams as unit. It already have a number there. Solution 1. Calibrate the instrument to the 0 mark. For the Newton scale, just pull this cover plate somehow that we align this with the 0 mark. For both electrical meters, you just need a flat screwdriver, and here on this screw, try to align, place the screwdriver on this screw, try to align the pointer to the 0 mark. And in the case of that, for example, the digital scale, you cannot fix to the 0 mark, and then go to solution 2, take your measurement and deduct the beginning mark before recording your value. Second problem, instrument malfunction due to aging. So this is a galvanometer. A galvanometer is an ammeter that measures small currents in the range of microamps. That's the problem. When installed in a circuit, this instrument pointer is not sensitive to the change of current. A possible solution: replace this instrument with another galvanometer, of course. Sometimes using outdated instruments, especially electrical meters, cause measurements error because these instruments become insensitive. Another source of systematic error is the manufacturer defect or instrument is damaged. Here we have 3 possible solutions. Solution 1, if the instrument is new, you can contact the manufacturer and see possible replacement or technical assistance. Solution 2 is repair the instrument if you have the skills and you have the tools. And solution 3 is replace the instrument with any available in your lab department. Now let's go to random error. The first one, measuring instrument is not set up properly. This is a common mistake in electric circuits. For example, this meter shows reading fluctuation. Possible solutions: check for loose wires or incorrect instrument settings, take a look on that, or even incorrect connections. Most lab experiments problems can be solved with visual inspections. Now, for when the measuring instrument is not set up properly, so as a solution, if multiple readings are not consistent, check for incorrect physical connections. The second source of random error, experimenter eye level is not aligned with instrument marks. It's hard to identify the correct marks on the ruler with eye level far from the instrument. To correct this, make sure your eye level is closer and use a pencil placed on the marks. When reading with your eye level at an angle, the marks will be showing higher or lower than the real value. This is parallax error. To prevent reading shifted to a higher or lower levels when taking readings, the experimenter must follow these techniques. Number 1, align eye level with instrument marks. Number 2, read close to the instrument marks. And finally, number 3, use a pencil, a string, a paper clip to aim the correct reading. So here is a solution for the second random error. Align eye level with instrument marks, read close to the instrument, and place a pencil or any other object over the instrument that you are reading so you can aim a little bit better. The third source of random error is inappropriate reading strategy. In this picture is showing a mirror ruler lean, causing a shift on the reading. To prevent this, place a ruler parallel to the spring. Another example is that holding instrument still while releasing a pendulum might be challenging for some. To fix this, place a protractor over a ring to prevent the string rubbing against it, creating friction, and at the same time, it makes it easier to release the pendulum at the correct angle. The objective of this lab experiment is to measure the time it takes for this cone falls from 1 meter high. Timer needs to be pressed twice. Once, twice. So the read time is a source of error. Human reaction time must be considered. As a solution, taking multiple readings and eliminate values of range. So here we have 4 trials and 4 measurements. Notice that the trial number 4, the measurement is off range when compared with the other trials. So on your computation, to calculate the mean average, you are going to eliminate the trial 4 and take in consideration just those values they are about the same range, 0.21, 0.19, and 0.18 divided by 3. So inappropriate reading strategy, the solution would be review your methods and make corrections. The last source of random errors is external factors like airflow, table vibration, background noise, amount of light. They all can be considered as external factors or external influences that is going to affect your reading. For example, this is a lever and these are in equilibrium, is being suspended over this ring. This is the fulcrum. So I have a force down here, a weight force, and another here. So one solution would be identify the source of the airflow and close a window. Another example is vibration of a table. So this vibration can actually cause the system, like during measurements and just everything fall apart and you have to put together again. Now you already took some measurements and now for this second time, your locations might not be the same. So it's important that you identify external factors that cause the apparatus be unstable and make the corrections and adjustments. Background light sometimes produces glare or shadow, blocking instrument marks. Also, background color blends with ruler marks, making difficult for the experimenter to identify the reading, the marks of the ruler. As a solution for this case, you can place a card behind to make readings more visible for the experimenter. Background noise can affect detecting sound from a pipe, causing incorrect measurements. A reliable lab readings results require a stable environment free of external influences. The most common are airflow, table vibration, background noise, amount of light, and unstable instrument. So external factors, solution, identify external sources. They are adding reading errors and making corrections. In summary, reliable lab results depend on measurements reading. There are many factors that can prevent effective readings caused by the instrument, the experimenter, or by the apparatus surroundings. It's important to construct your apparatus following written procedures and diagrams directions. Make sure to inspect measuring instruments for the correct calibration and read instruments at the eye level. After a few readings, if your values are not showing consistency, check for any visual malfunction, including instruments and the presence of external disturbances that can cause your system unstable.